Again, welcome to Data Science Using R. This is our Unit 1 lectures, Introduction to Data Science. So first we start with why data science. It's one of the fastest growing fields in the world. Demand expected to increase in the future. Also, the number one reason why data science remains the top job in America is because we have shortage of talent. It's a new emerging field. So what is data science? Data science, the main goal of a data scientist or the process of data science is to try to find a knowledge or a pattern or develop a model, optimal model from a large data set using data analysis algorithms such as machine learning, statistics, algorithms. So data science is the adaptive, interactive, and also phased approach to the analysis of data. Also performed within a systematic framework that uncovers optimal models. So by assessing and also accounting for true cause of prediction errors. Data science is a multi-field major. It covers, for example, statistics concepts, computer science such as database, machine learning, artificial intelligence. So it's again interdisciplinary field. Also, it uncovers nuggets of information from large data sets. So we can see that again, data science and data mining are almost the same, but again, there's a major difference. Data science also deal with the big data analysis using more complex algorithms like paracomputing. So what is data science? Again, here we say data science allows us to extract knowledge from databases. It lets people leverage large amount of data and computing power to tackle complex questions. So I would say this is the major difference between data mining and data science. For example, in data mining, we do classification, cross-story, association, task. The same thing applies to data science. But data science also, when we have a very large amount of data, such as big data, then we have to find a way to, again, use the concept of paracomputing, where instead of taking the data to the algorithm, we bring the algorithm to the data. So we may have a data in the different locations and use the paracompute. Example would be a Hadoop map reduce concept. So in data science, we are going to use Hadoop map reduce for analysis, again, a large data set. Also, patterns can arise which could not have been uncovered otherwise. And this discovery can lead to, again, a powerful result. So a data science methodology, we are going to follow the concept here. This is adapted by RSIP-DM, which is the cross-industry standard practice for data mining. So the same phases here we use also in data mining. So for example, the process is, first thing we need to do is the problem understanding phase, the first step. So if we have any tasks in data science, the goal of a data scientist is to solve a problem using the company's or an organization data and also applying some data science algorithms such as machine learning. So the first phase is to understand the problem that we are trying to solve. Then from there, we move on to the data preparation phase. So data preparation phase is when we are going to clean the data and we make sure the data is ready for analysis. So after data preparation, we move to exploratory data analysis. This is where we are going to understand our data. For example, doing such as a descriptive statistics, finding the mean, median, mode, variance, standard deviation, quartiles. Again, exploratory data analysis is The main goal here is to understand our data. Also, we can do visualization of the data if we can find any pattern. After that, the next we move to the setup phase. Then again, we are going to apply the data science algorithm to create our modeling. So that's the modeling phase. Then the result, we are going to evaluate it. When we evaluate our result, the next step is deployment. So we will go through all this step one at a time. So first we start with the problem understanding phase. Here we say that teams often work hard to solve a problem, only to find they solve the wrong problem. Excuse me, the wrong problem. So first thing we need to do is to understand the problem that we want to solve. The main objective, what should be input, what should be output, or the idea of the whole problem. So we need to translate the objectives into a problem that can be solved using data science. So the first phase, again, understanding the problem. Then the second phase, we are going to do data preparation. This is where we normally spend a lot of time. So we can do transformation of data, standardization, also identify the outliers. If possible, we are going to recode in the data values or reclassify categorical variables. We can also do discretization, which is binding numerical values. Again, we will go through these steps as we move on with the lectures, the class. But again, data preparation is again using some techniques, converting the raw data from data-based system or repository that need to be cleaned. So some of the techniques we can use to identify the outliers, transforming and standardize the data, reclassify categorical variables, binding the numerical variables, and also adding an index field. The next phase will be the exploratory data analysis. Most of the techniques here is based on, again, statistics. So we can begin to explore and learn the basic information about the data to understand the data. Not the time for complex algorithm. So most basic one, we can do the descriptive statistics, exploring univariate relationships like finding the mean, median, etc. Also, we can explore the multivariate if we want to find the relationship among different variables. Also, we can do binding based on the predictive values. In chapter 4 or unit 4 of our lectures, we are going to cover the exploratory data analysis. Then we have the setup phase. This is where we're almost ready to start our modeling or to start the process of data analysis, where we are going to apply the machine learning algorithm on the data. So nearly ready to model, need to take care of. We do our cross-validation. This is necessary to avoid the data dredging. Also, data partition need to be evaluated. Also, balancing the data, we need to enhance the ability of setting algorithms. Then we need to also establish the baseline performance so that we can again calibrate our models and determine whether they are any good. Then in the fifth phase is called the modeling phase. This is where we are going to apply our algorithm to uncover the relationship hidden in the data. So for example, if we are doing classification, this is where we apply our classification algorithm to the data that has already been processed or prepared. So here we need to select and implement the appropriate algorithms based on the task that we want to achieve. For example, we have 3 major tasks, which is classification, cross-story, and association. So classification means we have a data set, which is a training data set. Example, we have a patients that have a disease A. We know all the attributes, and we also have the target variable, whether they have disease A or not, yes or no. So I'm going to use this training data set to build a model. Then next, I'm going to use the test set. In the test set, I don't have the target variable, whether they have the disease or not. Now is the model have to make the decision for me. So here we are going to build a classification model to predict whether a patient have disease or not. Then we have Crossstory. Crossstory means we are going to apply the Crossstory algorithm. So similar attributes or similar values will be clustered together as one. The similar values will be in different clusters. So example will be a market segmentation. We divide into a partition based on the similarity. And the most common algorithm we use to measure the similarity will be the distance, finding the distance between the objects. So here we're making sure that our models outperform the baseline models. We need to, especially in classification, we need to find the accuracy of the algorithm, how it's percentage of correctly classified. Then next we go to the evaluation phase. So this is where we are going to again measure how effective the algorithm is. So your models need to be evaluated against the baseline performance measured from the setup phase. Also, we need to determine whether our models are actually solving the problem at hand. Also, we need to apply error costs intrinsic to the data, because data-driven cost evaluation is the best way to model the actual costs involved. So after the evaluation phase, then we go to the final phase, which is the deployment phase. So here we can report to the management on our best model. Then we work with the management to adapt the models for deployment. So finally, we can write a report, a simple example, also stay informed with the project. And we need to participate in the meetings and process involved in the model deployment so that they stay focused on the problem at hand. So a data science methodology is normally interactive and adaptive. When we say adaptive, sometimes it's necessary to return to a previous phase. So I may be on phase one, problem understanding phase. I went through data preparation phase, and I did the exploratory data analysis, but I found out something's wrong. I may go back to the objective of my project, which is all the way from the beginning again. Or I may be in the fifth phase, and we may decide to go to the third or first phase because we found some issues. So it's an adaptive process and also interactive. So sometimes necessary to return to a previous phase based on the knowledge gained in the current phase. Also, the models we created serve as input to the investigation of a related problem. So here we have the outer ring of arrows showing recycle of older models used as input. So what we mean, we can see the outer arrows, we are going from one phase to another. But sometimes with the inner arrow, we can move from data preparation phase to exploratory data analysis. Then we may see some issue. We can go back to data preparation phase or go all the way back to problem understanding phase. We cannot go to deployment no more. Deployment is the last final stage where we deploy the system. So before deployment, we need to evaluate our results, the model, and make sure it's in good shape before. But between problem understanding phase up to evaluation phase, we can do our interactive, go back to previous, and then moving forward. So what are the data science tasks? The most common data science tasks are, again, description, estimation, classification, cross-story, prediction, and association. We will go through all the tasks here by each lectures. But now let's just give a definition of each of these tasks. And later on again, in our next lectures, we may start with description, estimation, etc. So description, here we say data science describe the patterns and trends. So describe a cluster of customers most likely to leave our company service as those with a high usage minutes and also high number of customer service calls. So our goal here is that we want to know the type of customers that may attract from our company, may leave our company to our competitors or to other companies. So here we find that we are doing a prediction based on if a customer is calling the customer service call too much, almost every day, too much calls, they have complaints always, the chance of leaving the company is very high. So when we have this data set, we can again describe or even predict whether a customer can attract based on the number of calls it makes to the service calls. Also, working with a marketing team, the analysis can then suggest possible intervention to exploit to retain such customers. So again, data science main goal is to be able to identify customers that have high chance of leaving the company before they leave. So if there's any intervention or any strategy we can do to retain the customer. Another example in a widespread use around the world, for example, when a sports announcer says that a baseball player has a lifetime batting average, which is the number of hits by at bat is 0.350, he or she is describing this player lifetime batting performance. So almost every chapter in the course book I'm using will contain examples of description task. So the next task will be estimation. We use this a lot in statistics also, the concept of estimation, point estimation or confidence interval estimation. So here will be the approximation. It's not exactly, but approximation of the value of numerical target variable using predictor variables. So we may use the concept of confidence interval also. We may have 5% error. So this will be built using records where the target values are known. The models learn which target values are associated with which predictor values. And also the estimation models can estimate the target values for new data for which the target value is unknown. So the concept of estimation is the same as classification, but classification will use the nominal value or data for its target variable, whereas estimation or prediction use again continuous value or numerical value. So the next is classification. So that's why with classification is similar to estimation, except that the target variable is categorical. So with classification, we use either categorical or nominal values. There's a disease, yes or no. There's a condition, true or false. Again, we are using nominal data. Now we predict that a stock price will be $30. This we can use the regression, or we can estimate also, we can use estimation. So perhaps this is the most widespread task, especially in medical applications, mostly based on diagnosing patients, different type of disease. Again, we can have a classification system. Example given here, they say mortgage lender interested in which of their customer is likely to default. So we can create a model based on a data that we have, customers that have been default before and some customers that they haven't default on their mortgage loan. So we can build a model and then from there we can predict it. So model will show complete record of actual default status of a past customers. So if we have the data of a past default status of customers, we can use that data to build a model. And that will give us the idea what kind of attributes or characteristics that a person, a customer that may default a loan may have. So here we're going to learn which attributes are associated with customers who default. Then we deploy new data to help classify customers most likely to default. So also we have Crossstory. So as we said earlier, Crossstory is to identify similar data. Then we group them together as one cluster. The similar data that are not similar, they will be in different clusters. So identify groups of similar records. Records in the cluster are similar to other records in the same cluster, but they are different from records in other clusters. So we need to find the workable clusters. Finding the workable cluster is useful in at least two respects. First, your client may be interested in the cluster profiles. That is detailed description of the characteristics of each cluster. And secondly, the clusters may themselves be used as input to classification or estimation model downstream. The next is prediction, which is similar to estimation or classification also, except the prediction will focus related to the future. So for example, a financial analysis may be interested in predicting the price of Apple stock in 3 months down the road. And this will represent estimation since price is a numerical value, and also it's prediction because it's related to the future. We also have association. The goal here is determine attribute, two or more attributes that have a relationship or they are associated. So determine which attributes are associated with each other, which means they have any association or relationship. We need to uncover rules for quantify relationship between attributes. So these association rules take the form: if antecedent, then consequent. So example will be, if the light is red, then stop. So it will be like if then rules. So that will be the conclusion of our first Unit 1 lectures. Again, in these lectures, we cover the concept of data science. And this is our, again, Unit 1 lectures. We cover what is data science, what are different types of data science stacks, why data science. So in our next lectures, we're going to cover the concept of data preparation. And again, thank you for your time.